So sometimes the quantum mid stack that encompasses all the methods for error handling is referred to as a quantum operating system. So how does this terminology influence how we view the quantum mid stack's role in quantum computing?
Okay, so you can think of a quantum operating system as the software needed to bridge between the end users and the hardware. So this is what is needed in order to be able to take a mathematical description of the algorithm designed by the computer scientist or the algorithm designers, and implement it and execute it on realistic quantum devices. So all these tasks related to error handling that I mentioned, which I was talking about earlier, these are actually critical for this ability. Not just error correction and not just error suppression and error mitigation, but also very much so for error correction. It requires a lot of effort to optimize the error correction processes with the circuitry related to syndrome measurement, decoding, and error correction. So these are all things that the mid-stack is doing. But this is not all that the mid-stack is doing. These tasks are intimately connected. These tasks that I mentioned, they're connected to other tasks, which are also critical and which can all be put sort of under the umbrella of quantum operating system. So for example, the task of compilation, as that I already mentioned before, one needs to express the quantum algorithm in the most efficient way in terms of native gates available to the specific device specific hardware that we're working on. And also in a way which takes into account the noise. For example, it would be a good idea if you have qubits which are not behaving so nicely at now at this particular moment that you want to run the algorithm, then you would like to avoid them. So this would be noise-aware compilation. And another related task would be transpilation, namely setting up these quantum gates on the geometrical layout of the particular hardware that we're working on, 1 or 2D or what have you. So again, this is of course all these things are intimately connected. So this is of course intimately connected also to compilation, and of course error suppression and error mitigation need to take the effects of these transpilation and recompilation on the final structure of the quantum circuit into account. And then yet another very important part is optimization of the algorithm itself. You want to make it as small as possible, and that is also related to all these tasks. And there's also the way the hybrid quantum part of the computer communicates and organizes with the classical part. Because we would like to as much of the computation as possible to be done classically, so you need to work on optimizing the partition. And all of this is controlled by this mid-stack part of the quantum stack. And so it makes most sense to put all these things together in one big basket, which can then be referred to by the name of a quantum operating system. So to your question, I think the terminology of quantum operating stack is very interesting here, since it sort of allows us to think about realizing the quantum software stack in analogy with the way the classical software stack is built or was designed. And I think this is a very important thing to do. I think the developers of quantum computers, they have a privilege, we have privilege, which our fellow classical computer scientists pioneers didn't have when building the first classical computers. And this is that we can draw analogies from the case of classical computers. And we can learn from that a lot. It allows us to understand better what are the needs in the quantum case and to sort of not make the same mistakes and be much more efficient in the development. Allows us to clarify the differences also. So a very important example is what I talked about before, that in the quantum case, handling noise is one of the main tasks of the quantum operating system, where this is not so important anymore in classical computers because the hardware is so much more better, so much more reliable and accurate in classical computers than in quantum computers, at least nowadays. And another important role of the quantum operating system is the handling of the classical and the quantum parts of the computation and the communication between those parts. And this, again, of course, doesn't exist in the classical case. So there are important differences.
Thank you for the overview. So